Okay, great. Thank you. All right, folks, so I misinformed you a little bit earlier. It's not going to be Matt that's giving the presentation. It's Emerson Huit from Snthesis. And there we go.
Yeah, ready.
All right, let's go ahead.
All right, good morning, everybody. I'm Emerson Huit. I lead Snthesis. We're building a software platform that accelerates biotech, bioinformaticists, and scientific data pipeline architects, and giving me kind of a uniquely holistic perspective on how the industry deals with scientific data. Today, we're looking for strategic partnerships with big companies like Bayer and Syngenta, as well as major university research groups. We're also looking for introductions to teams that have major scientific data sets that they're dealing with, and we're looking for feedback on our narrative, because we're also pitching at CED. Currently, scientific research is undergoing a transition from human scale, where work was done by hand, to machine scale, where automation gives each researcher a huge amount of impact. At the same time, new methods are giving researchers an incredible ability to generate new data at amazing paces. Currently, data sets double every 7 months, which sounds amazing, but inside of that amazing achievement lies a hidden secret that as good as we are at creating new data, we're very bad at organizing it to generate long-term value. Manual processes are at the heart of data analysis today. From finding and preparing data for analysis, connected in ways that make it useful, everything is very high touch. As a result of that, highly paid experts spend most of their time simply preparing data rather than answering questions that matter. This means that the time it takes to turn data into valuable information is very long, often measured in weeks or months. And because of those problems, data frequently gets only used one time. That's a huge problem for the industry. $20 billion gets spent every year on tools and services to do data analysis. And that manual time I mentioned is about $10 billion of salary across the industry. And additionally, $7 billion is spent on research that fails because of data problems. Science doesn't have to be that way, though. Data can be validated and prepared automatically as it's captured. Systems can understand what data is and how it relates to other things and make connections automatically to uncover hidden value. And ultimately, data could be as simple to search as the web is with Google. In that world, data scientists would be free to focus on their analysis, and researchers could focus on their work rather than on the challenge of organizing data. Snthesis makes that world possible by capturing all of the data the lab generates, agnostic of format, including things like handwritten notes and pictures of lab notebooks, from which we extract text and make it fully searchable, and raw files of any type, and also data that's generated directly by experiments. As that data flows through our system, it gets categorized automatically and connected up to all other related data and supporting documents. It then gets checked for validity and for unusual values so that they can be flagged for human intervention, and we convert everything into a similar format so that analysis is easier for scientists. Finally, we leverage that categorization and classification so that we can give scientists powerful search tools that allow them to discover information. And because everything is linked, clicking on a single piece of information reveals everything it's connected to within the system. You can upload anything through a unified capture interface, whether it's a picture, a sequence file, or a lab notebook. Our platform works on mobile devices and desktops, so you can capture data when it's connected. And once that data is in the system, it flows into our proprietary discovery engine that converts into what's known as a knowledge graph, which is essentially a connected representation of the data that links up every piece of information that an organization possesses, as well as connecting to public data sets. This is the area where partnerships are the most useful to us, because we're working on some basic research to advance the state of the art and doing this automatically. So organizations that have large data sets that are poorly organized and are interested in collaborating are the ones that we want to talk to. Our search is simple and powerful. It gives scientists the ability to find even the most complex questions with natural language or through a graphical interface. With Snthesis, access to organized, searchable, and context-rich data streams becomes the default, which means that data is a fully reusable asset. We sell our platform as a software-as-a-service solution that's fully managed, but which resides on customer infrastructure. There's never a question about who owns the data. We make money in 3 ways. through customer implementations, recurring license revenue, and consultative support for research groups. Right now, our annual revenue is about $1.2 million, and we forecast 3x growth by the end of next year, or rather within 12 months. Looking forward, the biotech market is extremely large. It's currently $447 billion. That's forecast to grow to $774 billion globally by 2024. As I mentioned, $20 billion gets spent on data management tooling today, and we believe that we can capture 5% of that market by selling to the labs at the forefront of high-velocity research. Doing that, there's an enormous potential for growth. We are, of course, not the only people doing this. There's sort of three major categories of competitors. One is traditional laboratory information management systems, which focus on rigid process to enable regulatory compliance. There's also kind of a second generation tier data management tools that are more flexible, but they still require a rigid definition up front of what you're going to be capturing. And then there are in-house development teams. A lot of organizations have recognized that being able to manage their data better than other companies is a competitive advantage. So they built these teams in-house, but they're often constrained by short-term solutions rather than long-term holistic thinking. Our advantage is that we use state-of-the-art search and analysis tools to capture everything and organize it after the fact. That means that as more people use our platform, its understanding gets better and better. So everybody's ability to organize their data improves with no risk to keep. Our customers, who are currently anonymous because they recognize that our tool is a part of their competitive advantage, recognize the power that it delivers to synthesis, or rather, recognize the power that synthesis delivers to their research. At the core of our success is our deep understanding of the challenges that these organizations are facing in dealing with their research, and our long history of solving them at industrial scales. We're a profitable, revenue-funded company solving a really important problem in science, and if you know of anybody that's interested or that would have feedback that would be helpful and helping us push the envelope, please let me know.
All right, questions?
It's a big risk.
Yeah, I know. You don't have hot coffee, so I'm willing to take it.
Yeah, exactly. Thanks for your presentation. Can you extrapolate data from handwritten notebooks, or are these like where scientists would tablet?
Yes, so that's a great question. Primarily the lab notebooks that we're working with are all handwritten. So things that we do, for instance, are extract things like sample identifiers and protocol names and reagent names and link that up in the knowledge graph so that all of that's connected. So for instance, if you have like sample 47 that's in somebody's lab notes, we can extract that, and every page of lab notebooks that mentions sample 47 is linked up to that in the knowledge graph and is discoverable through search.
Is there any language restrictions?
Right now, we're focusing mostly on English. The United States is the bulk of the biotech market these days. There's a significant push in China, so there is an opportunity there as well. However, because of the more recency of that market, they're primarily using electronic lab notebooks. So those are tools that we integrate with as well, but that's easier because we don't have to do with the handwriting recognition.
Yeah, I enjoyed the presentation. A couple of thoughts. Number one, this goes similar to what we saw with the earlier presentation with the narrative. I think you have to decide to whom you're going to present. So if it's going to be investors, there's one conversation about this. And if it's customers and people who are offering you insight, I think it's another conversation. Because at one point you said we use state-of-the-art tools. That's a red flag for everyone. When you use that generic phrase, I need to know what that state-of-the-art is.
Okay.
If you're talking to an investor, because that's a competitive advantage.
Yeah.
Okay. Part two is longer term. I can talk about how a company who sees that they can manage their data more effectively creates a competitive advantage. Well, if I'm purchasing this and my competition purchases this, isn't that competitive advantage negated? So my point to you is not to describe this as a competitive advantage, but to think more effectively about how the organizations can seed research, can scale research, and then can engage researchers globally with their different parts of their company, as opposed to this offers a competitive advantage, because in a lot of ways that's become another generic term.
Yeah. Thanks, that's really good feedback.
So you're focused on the biotech market and
Yes.
research, R&D for science. Have you considered potentially using this either in fintech, supply chain? You know, these are industries that have massive data sets, and frankly, they've got a lot more money to pay you. So,
They do. The competition is also a lot more fierce. I mean, fintech is a pretty saturated market in terms of data management tools.
with using the same sorts of special sauce that the gentleman was referring to, you know,
Somewhat. I mean, so fintech has things like, for instance, like the Bloomberg terminal. Life science has nothing like that. So that's really like one of the thrusts that we're aiming to be is like the Bloomberg terminal for all of your research.
okay, so you're taking it the other direction, applying something that's already being applied in fintech and working it backwards into scientific research.
Precisely. And we have had some other markets that are very interested actually. So like law enforcement is a group that's been very interested because a lot of their data ends up managed in like notes. Some of them are moving towards like app-based investigative notes, but a lot of them are like handwritten notes. And they have like huge spreadsheets that are tracking things like, for instance, opioids as they flow through the state. So we've had some very interesting conversations there, but at the same time, like that's pretty outside of our wheelhouse. So we're trying to stay pretty focused on biotech because that's where my background is and that's where I've personally experienced this pain. And it's a pretty huge pain for them. Granted, there are a lot of like really other large markets that we can target downstream.
No, but that's a good example that you drew, or a scenario that I think a lot of people would relate to. So I just, nice way to kick it off and say, hey, we could be the, I know that's not usually what most people like to hear, but it's a really good example of Bloomberg for scientists.
Thank you.
Thanks, I really enjoyed the presentation. And, you know, just like your style, doing that well. It's like, how is this different from like something like Google? Obviously, they have this data set as their kind of scientific search engine that they rolled out. So, just explain to me how what you're doing is different there. And then we can talk offline after this. A couple friends of mine are biostatisticians.
Yeah.
And you know, they're not like decision makers; they're sort of the rank and file under hunters. If that's helpful to you, let me know. How
Yeah, those are really interesting conversations to have with folks like that. We're always interested in getting more people's perspective on it. The primary difference is like tools like Google's search tool, for instance, and other tools. For instance, like a lot of groups are using Amazon file services to do like similar analysis. Is that there's like a huge amount of manual work that has to happen up front to get the data into the system and make it searchable. And so our primary focus is on bridging that gap between like the scientists at the bench collecting data and putting it into whatever analysis pipeline is already present. And that big gap in the middle is where data science teams are spending 60% of their time today. That's a huge waste because they're getting paid like, something like $17 billion gets spent on that data scientist salaries in the industry. So like 60% of that is like more than $10 billion that's wasted on people basically moving data from point A to point B.
I thought your presentation was great. As a non-scientific person, I felt like I was able to follow and understand a lot of your key points. One piece of feedback was that sometimes I found you talking a little fast. And just especially compared to a scientific thing, if you're trying to do a non-scientific group, you might just want to slow down a little bit.
Yeah.
But I did have a clarifying question. When you talk, because you, based on what you just said to him about this is only for biotech, so does that mean the market size, when you're talking about the 37 million per year, that's only for biotech?
That is only the spend in the biotech industry today.
Wow. Yeah, I almost feel like that would be a really good point to really hammer home at that time, and maybe you did, and I just didn't catch it, because when you're talking about potentially long-term expanding to other markets, that makes your market size inflate significantly.
Yeah, absolutely. That's a really good feedback point that is really stressed out.
Question. I know you're doing a biotech. FDA has every IPR platform right there, which I can take and implement it. And why don't you take that platform and take all that data, because they have all the stages like they're beginning process to do this data and all that stuff. Why don't you take that platform for biotechs and implement it on the platform where it's an open source?
Are you talking about for the FDA?
Yes.
Yes. So eventually we would like to expand into those regulatory markets. There are some logistical hurdles that mean that's not our focus right now. Basically, there are a number of certifications that are quite expensive, at least for a startup to work in that space. Companies that are doing FDA-related regulatory things are typically pretty reluctant to use open source tools. So if we were to open source it, absent things like, for instance, SOC 2 attestation and
No, what I'm
CFR 2111 compliance, people are going to be reluctant to use it in that market.
question, FDA has an API, you know what I'm saying, it's an open source. You can take that platform and implement it to yours, and then you can extract all the data that's in there, the early stages, researchers and started and all that. It's there, it's an open source.
Yes, so that actually, so like using API data, for instance, from the FDA, there's a huge range of other scientific data that's available online like that. It's exposed typically in a format called RTF, and that makes it very easy to link up with things in our knowledge graph. So it's one of the advantages of keeping things in the knowledge graph is it allows us to connect to public data like the FDA or things like NCBI or European data sets very easily.
You mentioned that lots of time and therefore money is spent on data analysis and a lot of it on non-analytical tasks like entering data. Do you have any numbers from your existing users on how much time and therefore money your product has saved?
Yeah, so I think I'll just go back a couple of slides here to the testimonials. The most striking one is one of our customers that's using it, it literally used to take them weeks to get to a valuable endpoint from new experimental data. Now that takes about 10 seconds from the time the scientist uploads it to the time it's available in their dashboards. So that's a pretty significant reduction.
Other questions? Yeah.
Maybe not a question, but just a suggestion, which you can choose to take or leave. You mentioned a couple of different services that you have in terms of the actual implementation and the software. So I think one of the things, and I totally understand that these quotes have to be anonymous based on their customers, it might be valuable to kind of quantify a little bit more around that implementation service. I imagine as an organization, the idea is daunting to actually transcribe all of those notebooks and input the data.
Right.
So I think you have a value proposition on the front end in terms of helping them implement it and saving their team's time. And then you have the value that you're displaying here with these quotes, which is how do we solve problems with that data?
Yeah.
And I think just kind of combining the two might make that a little bit more valuable for you, depending on who you're speaking to.
Yeah, that's really good feedback.
Okay, two things. First, if you can put their first name there instead of anonymous, it's a lot more powerful. You don't have to put their company or anything like that. And then if you could turn those weeks to instance into a dollar amount or percent saved or something like that, it's an even more powerful thing. The thing I would ask you is, when we talked earlier, we were talking about the kind of connections that you're looking for. Can you talk a little bit more about the role or the job that somebody has, the job title, the thing that they do, and why that would be a good connection for you so that we can kind of think about our network?
Absolutely. So the most useful connection probably is either a research lead or a head of data science at a large research group or university or a large company, for instance, again, Snthesis or Bayer or IQVIA. But basically anybody that's leading a research team or dealing with large amounts of data is really helpful for us to talk to, because they've got obviously their own specific ways that they organize data, and we think we've solved a lot of those problems, but it's always good to get more feedback and more people's ideas.
So two questions. With regards to large amounts of data, are you talking about just sort of individual numbers where you got 3 million people in some scientific study and it's all these data points about that, or I have fewer units but it's larger in terms of file size? I'm thinking images.
Yeah.
And a follow-up to that as well.
Both actually. So some of the groups we're working with have huge collections of genomes, and previously genomes were several gigabytes in size. With sequencing technology today, each sample can be half a terabyte at least for all of the various kinds of sequence data you get off next generation sequencing machines. So we handle data of that size. For instance, we've got one customer that has literally hundreds of thousands of genomes and billions and billions of records about each genome. We also handle, we're working with a lab that has very, very large images. So things like 4 terabyte, like very high resolution hyperspectral time lapses. And we manage that data as well. That data does not reside in our system. That's in like their own proprietary storage solution, but we store all of the metadata and make that searchable and discoverable with pointers back to that existing data.
Okay, that's helpful. And then, so the follow-up to that is, in that second example, is your software performing the analysis on that imagery?
Our software is performing the discovery on that imagery. So like one of the big problems that particular group is they have like an entire closet with hard drives on it in it. And each one of those hard drives might have like 10 or 15 of these time lapses, and they're labeled based on the grad student that did that work. So it's very difficult. Like if you need to go back like 6 months, it's difficult. If you need to go back 3 or 4 years, basically good luck. If you can find the person that labeled it, you might be able to find your data. Otherwise, maybe not. And so what we do is like we take all of that data, we run our tool over it, extract all of the metadata. We do things like image analysis to read labels out of the time lapse and make that part of the metadata so it's discoverable. We don't actually do any like the advanced analytics on the image.
Okay. You triggered a lot more questions, so I'll tag it offline.
Absolutely.
I just have another idea based on this remark about changing the anonymous. I don't know for me. My thought was, as something anonymous, could you put a qualifier for what they are? So,
Yeah.
Research lead at Fortune 500 biotech company or something to help
Yeah,
people see who it is that's actually benefiting from this, they can see themselves in it too.
Yeah, that's a really good idea.
Yeah, eventually. Thank you. Didn't want to take the risk again. Yes, I'm BSF. I'm from BSF. Play biotech. I don't do that anymore. But one of the things to give people an idea of the magnitude of the data they're dealing with, plant biotechnology can take years, up to a decade, to get to a final end product, especially if you're dealing with genomes.
Right.
And then you have on top of that the staff transition in the labs, because people don't always stay there. BSF, people are moving everywhere all the time. And so you have the transitions in like the notebooks and how they're handled. And so if you have a solution to that, then maybe interject something like that. I mean,
Yeah, that's actually one of the things we're working on. Like that's one of the thrust of our basic research is to automate the construction of what's called an ontology, which is basically the categorization of that data and the labeling of it, and then to overlay a translate feature very akin to like Google Translate that allows us to map between one research ontology to another, so that it makes it possible to like when you have those different labeling schemes to translate between them. And that's really useful within individual groups, and it's also really useful when you have like multiple teams working on the same things. They tend to develop silos. That helps to bridge those silos when you can translate from one group to go to other groups.
yeah, I think so. Go beyond just saying you do data management. I think you can get people really excited when you say, we can do data management.
Yeah.
Yeah.
Yeah, that's really good feedback. Thank you.
So my question was also about the lab. This might be a little in the weeds, but my wife's a senior scientist, and I was thinking about, I think you mentioned running the software over from a metadata and tagging perspective, but you're not actually transcribing the pages, because I mean, there's a lot of different handwriting and everything else. Are you just kind of leading people to an image that's scanned in the lab, or are you like filing that in as searchable data?
We're scanning and converting to searchable data. So actually, like handwriting recognition itself is actually quite good. It's like the state-of-the-art models are like 99.6% accurate compared to a human. So it's pretty easy to convert most things into text. There are some things that are very common in lab notebooks that are more different, or more there, because that's obviously like a big source of data. Because you might have made a table in your lab notebook and put your results there, and it's a real pain if you have to transcribe that to Excel later or like enter it in a web form. So we're trying to automate that. But right now we're just pulling out like basically text to do keyword search on, and then eventually we'll move that forward so we're actually pulling out like real structured data.
Last question.
Good morning. Not a question actually, just a couple of contacts. I know a lab manager at BASF and a lab rat at UNC, so if you want to talk to me afterwards, I can.
Absolutely, it'd be great.
All right. Thank you very much, Emerson.
You can now consider yourself to have been fun. I throw this to Matt, but I don't think that would be.
That is unwise.